Hi, I'm Tom, and in this tutorial for Revit I will show you how to create surface hedge patterns from scratch. So first I will show you an easy one, which is a surface pattern which represents tiles 600 by 600 millimeters. Then I will show you how to create a more difficult one, which are these hardwood tiles, which go like this, 900 by 150, and they are crossed like this. And then I will show you how to create Viennese Cross, which is quite difficult surface pattern. And to show you the Viennese Cross, it looks like this, and in real life it's used in my home country in Czech Republic. It looks like this and it's quite nice. Okay, so let's get started. Let's close this project and let's open an empty one. We'll start with the easiest one, which are tiles 600 by 600 millimeters. So I will choose my floor, go to the definition of the floor, go to the structure, and here I've got my finish layer, and I will assign material, and I will create a new material, and I will name it tiles 600 by 600 millimeters. And here in the surface pattern I will click here, and we will be creating model pattern, surface pattern. If you don't know the difference between drafting and model surface pattern, you can check out my tutorial on the difference between these two. It will be in the description below. So here I will create a model, and I will create a new one, and I will name it tiles 600 by 600. And here I can create a really simple pattern. It will be not parallel lines, I want to have them crossed, so it will be both ways. The line angle will be 0, so it's horizontal and vertical. And line spacing 1 will be 600 millimeters, and line spacing 2 will be again 600 millimeters. Then I click OK, OK, and I've got my new pattern, tiles 600 by 600. I will go OK, 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 and now you can see it in my 3D view. When I open my plan view, you can see the pattern is here, and when I create dimensions, you can see it's 600 by 600 millimeters. So this is really easy. Now let's create the more difficult one, which are these hardwood tiles, and for this we will have to create a new file. So let's go to desktop, and I will create new, and it's just a simple text document, and I will name it hardwood tiles. Oops. Okay, now I open the document, and here I will define my surface pattern. The definition of the certain surface pattern actually comes from AutoCAD, and it's defined, each line is defined by its angle, origin, x origin of the beginning, y origin of the beginning, and then delta x, which is the difference between each line. Delta y is the difference in y-axis, and then the definition of the line type, whether it's dashed, dotted, and so on. So it's angle, xy origin, delta x, delta y, and then the definition of the line. So let's start with our file, and since we are creating it for Revit, we have to start with defining units. So we will write semicolon % units equals millimeters. This is for the whole file. And now the definition of the surface pattern starts with star and the pattern name. So we will write star and I will name it hardwood 150 by 900, comma, and now there's description. You can write whatever you want here. It's just a description. Now the next line, again, because we are creating this surface pattern for Revit, we have to write down that it will be model surface pattern. So again, semicolon percent type equals model. Okay, and then on the next line we start actually with defining our surface pattern. So first we will define, let's say I will take the start of my surface pattern here, this point. So this is y-axis, this is x-axis, and first we will create these lines. So this line starts first. We will have to put in the angle. So the angle is, it goes to the right, so it's 0 degrees. It's the same angle as you are used to in AutoCAD. So I will write 0, comma. Okay. Then we have to define x origin and y origin. Because the line starts here, x origin is 0, y origin is also 0. So let's write 0, comma 0. And now we have to write in delta x and delta y. What does this mean? It means difference between each lines in the x-axis and y-axis. So in x-axis there will be none, but in y-axis it's this difference between each of the lines, and this difference is 150. So in x it will be 0, and in y it will be 150. And now here then there's the definition of the line pattern, and because we have continuous line, we don't have to define this, so this is enough for us for the first line. Let's save the file. I will save it. Let's close it and let's load it into our project. But first, the patterns are defined not in plain text files, but the extension is .pat, so we have to rename the file. Let's rename hardwoodtiles.pat, and I want to change it. It still stays the same. You can edit it. On your computer you will probably have to right click on it and choose open with, and then choose either WordPad or maybe Notepad, and then you will be able to open it again in the text editor. It still stays the same. So now let's go to our project and let's see what we have created. Let's edit the floor and let's change the material, and let's create a new one and name it hardwood 900 by 150, and let's load the file pattern. Let's load the model, create a new one, name it, we don't have to name it because it will take the name from the file. We will choose custom and we will browse. I'll go to desktop and choose my file hardwoodtiles.pat. Oops, so what's the problem? Okay, let's see. Let's look at the file. And I have forgotten comma here. So now let's save the file, go back to Revit, browse, and load the file. You can see that the name is taken from the file, and we've got these lines which should be 150 millimeters apart from each other. So let's check it out. Let's see how it looks in our project. When I dimension the distance between these two lines, it's 150. Okay, let's continue with our definition of our pattern. Now we will start to create these lines, and this is actually one line, but it's dashed. It's 150, and then there's a space 150, and then there's 150, so it's just one line and it's dashed. The angle of the line is this one, so it's 90 degrees. And this is all we need to create this line. So let's start. We started already a new line. The angle will be 90 degrees, comma. These two are the origin. The origin is here. X and Y is both 0. So 0, 0, comma. Don't forget about that. And now let's see the offset of the lines is rotated by this angle. So now the offset between these two is not in x-axis but in y-axis because it's rotated by 90 degrees. So in x-axis it's 0, comma, and in y-axis this distance and this distance is always 900 millimeters. So it's 900. But now we have to also write comma, and we have to create the definition of the dashed lines. 150 and then 150 space. So to create the dashed lines, you write the number, the length of the dash, and then when you write with minus, it makes the empty space. So this will be with minus, and this again will be the plus, and it repeats again and again. So the definition is 150, that's the length of this line, and then comma minus 150, and that's the definition of the empty space because it's with minus. And then it repeats itself again and again and again, so we don't have to write anything more. We will save the file, and let's take a look at it again in Revit. Let's select the floor, edit type, go to the material and edit the pattern, and let's just browse again and reload it again. You can see, when we go to OK, that we have created these lines like this, and they are 900 millimeters apart, and then there's 150 dash and 150 space. Now the last line that's missing is we have created this one. Now we need to create this one. Okay, so again let's go to our file, new line. The angle will be again 90, comma, the beginning of the line in x-axis is this difference. Okay, so it's 450 because it starts here, not at the beginning of the definition of our pattern. So it will be 450, comma, and in y-axis it's 0. Okay, comma, and then let's set the differences between each lines. So it's this difference. Okay, and again it's 900 millimeters, but we have to be careful because the angle is 90. So again this is rotated, so the difference is between in the y-axis. So it's again 0, 900, comma. Now let's create the definition of the of the line, and because the line starts here in this point and goes up, it starts with the empty space, not with the line. So we will start with minus 150, comma, it's this empty space, and then this line is continuous line, so it will be 150. Okay, now save the file, and let's reload the hedge pattern again in our file. So let's modify this hardwood, let's browse again, load it, and let's see. Okay, those are the dimensions, no problem, but that's not a big deal. Now let's see, when I isolate the element, you can see that if the hedge starts here, this is the line that we created previously, and this line we created now. So this looks properly. When we dimension it from here to here to here, it's 450, from here to here it's 900, and then again each plank is 150 millimeters wide. Now let's go and start creating the Viennese Cross hedge pattern, but first warning, this is quite difficult, it's not that easy, and it's quite time consuming. So if you have a full version of Revit, I would recommend you to go to the Revit Pure site and check out the Revit add-on, which will enable you to create the surface patterns automatically by script, not by hand, as I will show you. You can also do it if you have a full version of AutoCAD and you have Express tools. There's a super hedge command which creates surface patterns. But for the sake of this tutorial, I will show you how to create pattern like this by hand. So first, I created a drafting view which has this Viennese Cross with some basic dimensions drafted. This will help me with taking some of the dimensions later. So now let's go to our desktop and let's create a new file, text document, and I will name it Viennese Cross. And yeah, I have to rename it again, and I will name it .pat text file. I will change it. Let's open the file, and now we will start again as previously, semicolon, percent, units equals millimeters. Then the name of the patterns, we'll start with the star. Name of the pattern, so I will name it Viennese Cross. Viennese Cross pattern. It's the description. And then again, semicolon, percent, model, type equals model. Now let's start with definition of the pattern. So first, the easy one, we will create this line and this line. They are just straight lines. So the angle is 0, the start is 0.0, offset is 0,500. Yes, and it's a full line, so we don't have to define other things. Now we will create angle 90, beginning again at the beginning of the definition of the file, and 0,500 again. Now it's important to always end the definition of the line patterns with an empty line. I will save the file and let's load it into Revit. Let's create a new material. So name it Viennese Cross. And let's load the model pattern. Let's create a new one. Custom browse Viennese Cross. Okay. Remove the dimensions. Now we see that we've got the basic cross 500 by 500. Okay. So now let's create these lines, and it will be always this line and it goes up here again. Okay, so let's go to the definition, and we can use comments when the line starts with the semicolon. Revit doesn't take it into account, so I will name this main square, and I will name this section sub square. So let's start with this line. Let's start with this line. The angle is 0, so let's start angle 0. The beginning of the line is this line, so I will take it as a line like this. So the beginning in x-axis is 0 and in y it's 80. So it starts here. Okay, so I'll call it in x-axis 0 and y-axis 80. Now the offset between each line, I will take it as this line and then on the next tile. So it's always 500. So in x-axis it's 0, in y-axis it's 500. Now comes the little bit more difficult part, which is definition of the line. How long is the empty space from here to here? How long is the line? And then how long is the empty space again? To find out these dimensions, I will go to Revit and I will go to my Viennese Cross, and I would like to dimension from here to here. It looks like 135, but I would like to have it more precise. So I will, because if it's not precise enough, after it goes for several other tiles, it will be more and more off. So I will create a new dimension style. I will duplicate this one. I will name it dimension precise, and I will change the color to blue so I will know these are precise. And in the unit formats, I will change it to custom, and I will go with 0,00001, let's say, and I will suppress the trailing zeros. Okay, so now when I go and dimension this, I have this 136 point something. Let's say I will take this as 136.5. This is because I will count it out. So first it starts with the empty space, which is 136.5. So let me go to my definition of the file, 136.5 with minus, then comma, here will be the length of the line, and then there will be the same empty space. So I will name here xxx, and then comma minus 136.5. So now we've got these two empty spaces defined, and we want to know how large this one is. I can actually count it on a calculator, so I will go 136.5 times 2, those are these two, minus 500, and that's 227. I know that the whole length should be 500. So 227, so 227. Okay, let's save the file. Let's see again how it looks like in our Revit file. I will open my material browser and then edit the Viennese Cross and then reload the Viennese Cross file again. Let's go OK, and this one looks as it should be. So now let's create this line, and it's actually at the angle of 90, and the beginning is, the x-axis will be 80, in the y it will start here at this point. Okay, so let's type in angle 90, then in the x-axis it starts at 80, y-axis it starts at 0. Now the differences between each line from here to the next tile, it's again 500, and it doesn't matter that it's rotated by 90 because it's always the y-axis difference. So I go 0 and 500 again. So be careful, it's quite confusing. The start point of the line doesn't change with this angle, but the offset changes with the angle. Okay, that's quite confusing. And now, so we are starting here, and we start again with an empty space, so it will be minus, then the line, and then the empty space again. Okay, so we can actually copy this, and we can copy here. Okay, so now let's save the file. It warns me about formatting, and let's reload. Let's reload our surface pattern. And you can see it's starting to look good. Okay, so let's take these back, and now we will create this line, which is the, let's start with this line, which is the same as this one, only it starts by some definition. It starts from here by 420. It's 500 minus 80. Okay, so now we can take this line, paste it here, and we will only change the starting point from 0,80 to 0,420. Okay, because it didn't start here, but it starts here. Okay, and the same will go with this line. It will be the same as this one, but it won't start here, but it will start here, so this dimension is 420. Okay, now let's take these steps back, and again let's copy this one, paste it here and make it 420. Save the file and see if it works in Revit again. Yes, this looks good. Now we'll start the most difficult part, which are these cross lines, and we will start with this one. So actually it's under the angle 45 degrees, so that's quite simple. Let's start new section, cross lines, and let's start the line. It's 45 degrees, and to see where it starts, in the y-axis it's 0 and in x-axis it's this distance. I don't know this distance. So I will go to Revit and I will use my precise dimensions, and I will dimension from the start of the pattern to this point. And it's this dimension. I will copy it to my clipboard, so I will copy, and now in my line definition I will paste it here, and in y-axis it's 0. Okay, so we've got the start of this line. Now let's do the offsets, and let's imagine it's a straight line without any empty spaces. So the x offset we don't care about, it will be 0, and the y offset is the distance to this line. So again in Revit I will copy this line from here to here, and then I will measure this distance, and this is my y offset. Okay, so I will copy. Let's go to the file definition, and x offset will be 0, y offset is the one that I have measured. Now let's save the file and check out in Revit. Oops. So let's reload the edge pattern again. Oh, what's the problem? Yeah, I see I have a problem with this comma, with copying the dimensions in the check format, and I have to add comma here. So this should work now. Let's browse again, reload references, and it looks like it's going in the right place. Okay, so now let's solve the length of this line, and actually when it starts here it goes up to here, and it should go up to here, the next tile. So I want to know the length of this and the length of this empty space. So I will go to Revit again, to my Viennese Cross, and I will create dimension from this point to this point. Then copy the length. So this will be the length, and then the space. I will trim these lines, and then I will dimension. I will actually create line which goes to here. I will trim it and dimension from here to here, and it's 80, so the empty space will be 80 minus 80. Okay, now let's save and reload in Revit. Browse, reload again. As you can see, it's quite tedious work to always check what you are doing, and when I will isolate the floor, and you can see at some places it works well, but at some places it's off, the space goes off. That's because when you create this line and this empty space and then you offset it to here, the empty space starts again perpendicular to this one. So we have to again move the empty space, so offset it in the x-axis. So it's this offset here. And how do we find this value? We go to Revit, to our Viennese Cross again, and I will draw a detail line. Now I'll draw it from here to here, and then again detail line from this point under the angle 45 degrees. And I will trim these. Oops, let's trim these. Now when I dimension this length, this is the x offset that we want to have. So I will copy this value and I will paste it instead of the x offset. And actually one more thing, because it goes from here to here, it's and the x-axis goes that direction, it's with minus. From here to here, it's it goes in the negative direction. So let's see if it works. Let's save the file and let's reload again. You see, reloading all the time. That's why I recommend the Revit extension, because as you see, this is quite tedious. But now the line works. So let's continue with this line. It will be quite similar to this one that we just created. It's just that it's not offset in the x-axis but in the y-axis. We can actually copy this line, paste it again, and then copy the x offset, or cut, paste it here, and let's save it like this. And I already know that it will work. Let's check it out. Browse again, reload. Now the last part will be the most difficult, and those are these two. Well, actually this line is dashed and it's dashed again here. So first let's start the angle. The angle is this one, which is 135. So let's go 135, and then it starts in x-axis by this dimension, which we already know this dimension. We had it here, so we will copy this again, and in calculator we will go 500 minus, paste the number, select all and copy, and x it will be this number, in y it will be 0. Now the offsets in both directions actually will be the same as these lines. Okay, it's just rotated by another 90 degrees. So this offset we already have, and actually there will be same offset in the x-axis. So we can copy these offsets from the previous line. Let's just don't forget comma. And also let's start with having the length and the empty space the same as this line. So let's copy these two lines and let's save and reload in Revit again. Let's save the project. Let's edit, browse, reload again. And you can see that this line looks quite nice. Now we will do this line. And actually, I won't be doing this line, but when we start here, I will be doing the one that goes from here to here. Okay? So these two lines have the same starting point. So the angle will be 135 and the starting point is in x-axis 0, in y-axis the same as this one. So let's copy this. And now we will copy this again because the offsets will be the same. Let's save and see in Revit again. It's always good to check because, I mean, if you are an expert in this, you will do it correctly every time, but I make mistakes all the time. So now it looks almost complete. We just have to take out these two parts. So these lines, the last two, have to be edited so they have empty space here. The empty space is actually 80 and we know the length of this line and the length of that line is 627 point this. So we will in our calculator insert this length, make it 80 shorter and then divide it by 2. Okay, so I actually took this line, took this away, and I had this length and I divided it by 2. So I will copy, select it, copy. Now this part I will make it so that it's the length that I have calculated, then minus 80 space, and then the length again. Okay, let's save it and let's actually copy this and do it here again and save the file. Now hopefully for the last time in Revit, let's reload the pattern file and voila, we've got the Viennese Cross surface edge pattern complete. Let's reset temporary height. Now I will align the edge pattern properly so it looks like this. So we have learned how to create custom edge pattern for Revit. We have learned the simplest one, these tiles, then a bit more difficult, the hardwood, and then the Viennese Cross. I would recommend, as you could see, creating such difficult surface patterns takes quite a lot of time, so I would recommend checking out the Revit extension. If you would like to have the Viennese Cross and the hardwood surface patterns, You can download them at Gumroad from the link below for free. Okay, I hope this helps and take care.